This short video will demonstrate how the StealthWatch solution will help detect an advanced targeted attack. Pretty much weekly we read about new data breaches that have occurred that are negatively impacting businesses. Findings from the 2014 Breach Level Index shows that the number of breach records has increased over 76% from previous years, and all industries have been impacted, with retail and financial being weighted a bit higher. Many of the breaches we read about illustrate that the attack was not super sophisticated, but instead the adversary is walking right in using stolen credentials. How do you detect a threat when the keys are being handed out and the adversary is walking in the front door? Many times these credentials have elevated privileges, which allows the attackers to have free rein once inside the network. Attacks can be associated with sabotage, espionage, data loss, or fraud, and is no longer a question of if you will be targeted. We need to come to the realization that the bad guys are already inside your network. Let's walk through what a targeted attack could look like within StealthWatch. 10.201.3.149 is compromised and Ken's username is used to get within the network. Ken's machine begins scanning internal subnets looking for devices with data. 10.201.0.72 responds and Ken's machine performs a port scan to find a management channel to connect to and steal data. The data is stolen and encrypted and uploaded to a Dropbox account of 60.10.254.10. This is an important note, as StealthWatch is able to detect threats by modeling session information, regardless if the data is encrypted or not. The Security Insight dashboard provides a high-level report of any systems that have triggered an alarm category, such as reconnaissance or data exfiltration. Let's view all of the hosts within the network and which hosts have raised an alarm category. We see that 10.201.3.149 has triggered several alarm categories, starting with the concern index to indicate this host is a threat, and then breaks the threat down into different stages, from reconnaissance to exfiltration. Clicking on 10.201.3.149, we are brought to a host snapshot view to get a clear picture of what this host is doing within the network. The alarm categories across the top indicate that this host is performing reconnaissance, has been hoarding data from other internal systems, and is now in the process of exfiltrating data. The host summary tells us this host is still active in the network. The user session information tells us that Ken is currently logged in from a Windows 7 workstation, and the MAC address shows that it is a Dell laptop. The traffic peer chart shows that the internal host Ken is connected to and what internet host his machine is connected to. Notice the unusual outside connections. The alarm report by type shows different security events that Ken's machine has triggered over time. Each event was an early indicator to block this traffic before a data exfiltration occurred. The application traffic graph shows what applications Ken's machine is using within the network today and over the past 7 days. SSH is currently heavily used, and external shows what applications are being used by Ken's machine and the internet, with 5.3 gig of HTTPS traffic being used. Pressing the View Flows button, we can get additional details and see a large SSH session between 10.201.3.149 and 10.201.0.72. We also see a connection from 10.201.3.149 and 60.10.254.10 in China with a large data transfer over HTTPS. Selecting View Additional Details, we see that a Dropbox URL was being accessed. As you can see, by collecting and baselining flow data to gain deep visibility within the network, StealthWatch is able to detect security events that could be the source of a targeted attack. Users are associated with these events, and all behavior is prioritized through alarm categories to detect events during the different stages of an attack.